this section, 8th graders will learn to work with more than one equation at a time. We will explore what it means for equations to have solutions together and how the lines they represent interact on a graph. Sometimes we need to study two rules or relationships at once to understand how they connect. A system of equations lets us see where two lines meet, or how two conditions can be true at the same time. This helps real-world tasks like comparing phone plans or figuring out the break-even point in business. System of linear equations. A set of two or more linear equations with the same variables. The goal is to have one set of solutions that satisfy all equations in the system, representing the point where the lines intersect. Simultaneous equations. Another name for a system of equations. The solution must satisfy all equations at the same time. Solution to a system of equations. The value or values of a variable that makes all equations in the system true at the same time. Different systems tell different stories. Some lines cross, some never meet, and some lie on top of each other. Knowing these types helps students understand whether a real-world situation has one answer, no answer, or many possibilities. This is important in fields like engineering, budgeting, and scheduling. Consistent system. A system of equations that has at least one solution. Inconsistent system. A system of equations that has no solution. These lines are parallel and never meet, so there is no solution. Infinite solutions. A system of equations where the equations describe the same line, so there are infinitely many solutions. These are really the same line, so any point on the line is a solution. To make sense of a system, we need strategies that help us find where the equations meet. Methods like substitution and elimination give us efficient ways to solve problems. These tools are used in everything from comparing price options to planning travel routes. Substitution method. Solving one equation for one variable and then plugging it into the other equation. Elimination method. Adding or subtracting equations to eliminate one variable, making it easier to solve. Lines on a graph can show many real-world patterns such as trends, directions, or the speed of movement. Understanding when these lines are parallel or perpendicular helps us read maps, design structures, and understand motion. These ideas also make graphing systems of equations much clearer. Parallel lines. Lines that never cross and always have the same slope. For example, the lines y equal 2x plus 1 and y equal 2x minus 3 are parallel. Slope of parallel lines. The slopes are equal. In the previous example, both lines have a slope of 2. Perpendicular lines. Lines that cross at a right angle. Y equals 2x plus 1 and y equals negative 1/2 x plus 3 are perpendicular. Slope of perpendicular lines. The slopes are negative reciprocals of each other. In the previous example, the slope of 2 and the slope of negative 1/2 are negative reciprocals.